Welcome to the training module of Bridge Resilience System. The training module of Bridge Resilience System is approximately 20 minutes video. On the login screen, use the username and the password provided to you. Once you log in, you will land on the home page of Bridge Resilience System. On this page, the first step you will have to do is download the user manuals. There are 4 manuals available for download. The first manual, which is very critical and must read, is the Bridge Resilience System Manual and System Implementation. The second manual is Guideline for Implementation of Risk and Vulnerability Analysis of Bridges. The other 2 documents are reference materials for your better understanding of the concept of bridge resilience. If you look at the left side, you will see a panel of buttons under the logo of Bridge Resilience System. The first button is the summary page, which is the page you are on. The second is for standard parameter. The third button is a toggle button to choose between culverts and bridges. It is named as Dashboard for Bridges or Culvert. The fourth button enables you to log out. We now will go to the standard parameter page. The home page for this standard parameter module will show the listing of all the years for which standard parameter have been created. You can create the standard parameter for a new year by clicking on the button Add New. The standard parameter refer to the parameters that are essential for analytical calculations of the bridge resilience system, and these parameters are constant for the whole year. It is essential that you enter the data here before you start the analysis. Do not change the data midway during operation of BRS. Changes will impact results of bridges you add after the change. The first input part refers to the general input in which you type the year, the country, average salary per week, fuel cost per liter. The unit provided is Indian rupees. This is just a unit for the sake of clarity. You can replace it by dollar or pound or dinar or ruble or whichever currency you want to. The figure is important. Next, enter data for the average passenger per vehicle and average speed on the network kilometers per hour. These are the general input. Then you come to define the critical route. In this part, you can select the type of road. You can add multiple critical routes for your region, so you can add 2 or 3 or 4 routes. Additional routes are added by pressing the Add Row button. Then we come to the economic and emission inputs. The figure of emission is standard and it is pre-flooded. Fuel consumption is also standard. Bridge maintenance budget is the department's budget for maintaining all the bridges on the network. And finally, we have the conversion ratio that is converting financial cost to economic cost. It is the ratio defined by the federal bank of the country you stay in, and it's generally between 0.85 or 0.9 or 0.95. Once you fill all these, you can press the button Submit and Continue. You will see the year in which you have added will be displayed in the home page. These figures can be edited. For editing, move to the right side. If you move your cursor to the extreme left extreme, we'll see a button Edit Standard Parameter, and the second is View Standard Parameter, so using the Edit button you can make changes. With this we have completed the Standard Parameter module. Now we move to the dashboard for bridges and culverts. Firstly, we will cover the culvert part. Under the home page of the culvert, it shows the list of culverts, for which data has already been input. It has a culvert ID, inspection date, created date, and action, so you can see that report. Please bear in mind that you cannot create iterations for culverts. Inspections seen are for the last inspection carried out. If you add the culvert, it will go to the next number. In our case, The last culvert number is C0007. Adding one culvert will increment the culvert number to C0008. Adding data for culvert has 4 basic inputs. The basic information, which has the date of inspection, road type, latitude, longitude, road name, inspector name, type of culvert. For type of culvert, you can select whether it is a box culvert or a slab or an arc or a pipe. And then for weather condition, we have sunny, cloudy, overcast, rainy, snowy. Then you go to the geometrical details, and in the geometrical details, you have the span length, rise, skew angle, clear width, the inlet shape, outlet shape. Next comes the distress type. The distress type basically covers different types of distress and the area of such distress. Example being cracking, spalling, delamination, so on. Then using few simple yes or no type of questions, data is collected for settlement, scouring, blockages, joint separation, deformation. Finally, you can type the conclusion in the conclusion page. Then press save. This saves the added culvert to the home page. All this added input you can see in the report of the home page. When you go to the home page and press the report button, you will see the entire report flashing out. You can print this report and save it. If you want to go back to the home page, press the button close. Now using the toggle button, move to the bridge module. Under bridges, use the button for listing and inspection data. On the home page, you can see the list of bridges available on the database. On the right top corner, you see a button, Add Bridges, using which you can add new bridges to the database. On the Add Bridge home screen, you will see 7 key modules. The first is bridge identity, location, and geometry, which requires the user to submit data for the date of inspection, code of the region, type of road, road number. The bridge number and bridge identity number are automatically generated. Next, the geospatial location and geometry data is required to be submitted, followed by substructure and foundation data, followed by superstructure and bearing data. Next, you have 9 questions for location-related data, followed by 4 questions related to the historical data of rehabilitation. Answering all the questions is mandatory. Using the bottom right side bottom button, move to next key data collection step, namely the symptoms of distress. Under symptoms of distress, you have details for cracking, delamination, spalling, distress near expansion joint, concrete disintegration, distress in bearing pad, so on. The next screen is the rating for structural, functional, and socioeconomic parameters. Under structural ratings, you have ratings for deck, superstructure, substructure, and foundation. The eye icon for each of this indicates, in short, the details of the drop-down that you see. Drop-down options being good condition, satisfactory condition, poor condition, critical condition, and failed condition. So for each of these ratings, you have the description that is provided in these ratings. Similarly, enter data for functional ratings, where you have the deck geometry, vertical clearance, waterway, and ADT. Under socioeconomic rating, we have rating for social importance, economic growth, alternate route, and environmental impact. Enter ratings for all the 12 above stated parameters. The next screen that you see is the cause identification rating and performance ratings. Under this, you have to provide ratings for all 12 different causes. Similar to the previous screen, the I button indicates the description details of the rating drop-down. Below these cause ratings, you can see one button which indicates is short-term SHM undertaken. If you select yes, then select one of the options. namely below 25% and above 25%. Select anyone. Next, you go to the Financial Detail, Estimated Rehab Cost, and Capital Cost screen. Here, the construction cost in million is calculated based on bridge length provided by you previously. Year of start of construction and year of completion is to be provided, which calculates the number of years for construction. Then you have to provide the annual maintenance cost in terms of percentage of capital cost, which is ranging from 0.5 up to 2%, and periodic maintenance cost again in terms of percentage of capital cost ranging from 2 to 4%. Estimated rehabilitation cost for the last inspection done is required to be submitted before moving on to the risk assessment screen. Under risk assessment screen, you have 4 hazards, namely flooding, cyclone, landslides, and earthquake. You need to click on all the 4 hazards and select the ratings for each of these hazards. The rating depends on the zone you are located in. Rating vary from moderate, high, very high to severe. Selecting indicates the level of hazard that occurs in your area. Next, you need to provide historical data by answering a set of 7 questions for each of those hazards. These 7 questions are related to the historical data of those hazards, like what was the duration of the last recorded event? What was the average intensity? What was the last known severe event occurrence? What percentage of bridge were heavily damaged, and so on. This captures the dynamism in the severity and frequency of the natural hazards. This completes all the data that is required for the bridge resilience system, and then you have the opportunity to upload images under Image Upload before pressing the Review and Submit for Analysis button. Once you press the Review and Submit for Analysis button, you will see a pop-up where key bridge data is seen. You can submit the data for analysis. The bridge is now visible on the home screen. For bridges listed on the Bridge Listing and Inspection screen, there are 4 action buttons that you see. The 4 buttons enables 1 to edit bridge record, view bridge results, add iterations, and accept and submit for analysis. Once the Accept and Submit for Analysis button is used, you cannot modify or edit the bridge data. All these results are then visible. For example, if you want to see any one particular bridge, you will see all the iterations that have been done. Including the iteration timeline and complete submitted data is visible for all the completed iterations of that bridge. This completes the Bridge Listing and Inspection Data screen. We now move to the Analytical and Financial Tools for Fund Optimization module. On the home screen, you can see 5 buttons. Namely, for the analytical result, bill of quantity, financial strategies and decision-making, risk and vulnerability analysis, and finally the button for fund optimization using multi-decision making criteria. Under Analytical Result, you will need to select the bridge and the year for which you need to view the results. Doing this, you can press the Filter button. You will see that the results pops up on the screen. The results of the analysis that have been done for the data that has been submitted. The first part of this result refers to the results required under Bridge Management, referring to the balance service life, absolute balance service life, deterioration process, and median service life. This is presented for both scenarios, namely pre-SHM and post-SHM scenario. For the bridge with age greater than 50 years, the 50-year balance service life and absolute balance service life shows a result as NA, meaning not applicable. Results for 100-year result are visible. Below this you have the 50-year graph and the 100-year graph indicating the median service life scenario, which can be used to decide the efficiency of rehabilitation process. Next is the financial due diligence results in the form of internal rate of return for both tangible and intangible results. Tangible refers to the direct benefit and intangible refers to the socio-economic benefit the bridge brings to the region. Next are the risk and vulnerability result for the 4 natural hazards. Displayed are the risk index calculated for flooding, cyclone, landslides, and earthquake. The value transferred to MCDM is also seen along with the zone selected and the severity or criticality. Next displayed are the failure analysis, which shows you the results for the probability of failure based on the historical data. Next table is the definition of the severity or rating of natural hazards for which the bridge with the present deterioration process is rendered safe. This defines the bridge safety definition in terms of velocity of floodwater and flood height for flooding and cyclone. Also for landslide, this is terms of velocity of sliding mass and its height. For earthquake, it refers to the NKS intensity and risk. Moving ahead to the risk and vulnerability analysis, we have on display the list of all the bridges on the database and the risk index evaluated for each of the 4 natural hazards and the value that is transferred to MCDM. So we have on one screen the entire list of results of risk and vulnerability analysis. In the top band, the summary of the results evaluated is seen. The next button we shall go to is the financial strategies and decision making. Displayed is the conclusion results emanating from this financial evaluation. It shows whether the bridge has to be rehabilitated urgently or bridge needs planned rehabilitation. In our database, only 2 bridges require immediate rehabilitation, and the balance bridges rehabilitation can be undertaken in the planned manner. The next module is for estimation of rehabilitation or enhancing resilience of the bridge. For both rehab and resilience BOQ generation, we have the option to view the list of bridges for which this process have been completed and also the option to create BOQ for a new bridge. The top band on each section shows the summary of BOQ generated. If you need to view the BOQ generated for any bridge, you can use the View button under the Action column. To create the BOQ, we can use the Create button. Then choose the bridge number and then create the record for that bridge. We need to select severity of distress before you move to enter other data. Then proceed to enter the quantities and rates for each items of work that are available. Available tables are general items applied over entire bridge prior to the start of rehabilitation, wearing surface repair and resurfacing, bearing and bearing pads repair, expansion joint repair, river training work and debris clearance, scour protection, so on. User can then use the cause matrix method, wherein for every cause we have predefined principle of rehab and work methods. Just enter the observed area of distress and rate for each item of work. The total rehab or resilience cost is estimated and saved in the database. These values are then used in the MCDM Fund Optimization module. Similar procedure can be used to generate the BOQ for enhancing the resilience. Once you select the level of severity, you can confirm the failure mode from the 3 modes outlined in the analytical results. Use the modes of failures which impact the bridge and decide the principles for operating the enhancement of resilience. Items of works then pops up. Add the observed quantity and rate, and then the amount is calculated to calculate the total resilience cost. The final tool in Bridge Resilience System is Fund Optimization Tool using the multi-criteria decision making. On the home screen, you will see the bridge selection. You have to select all the bridges that you need to apply MCDM. Care is suggested. All bridges on critical routes are kept out of fund optimization process, and entire rehab and resilience cost for these bridges are deducted from available budget. Having selected the bridge, then you have to select the criterions. For criteria are defined, and that is why it is called the multi-criteria decision-making tool. The first is the structural status. Then you can choose from risk assessment, financial impact, and socioeconomic. The impact for each of the 4 rank is seen in AHP, where the rank determines the weight age assigned. Then the weight age for comparison between one rank and the next rank is done for all possible permutations. Subsequently, select the year for which you need to apply fund optimization. It will then automatically floods the other data. Lastly, on pressing the Analyze button, you get to see the results in the form of 3 tables. First table ranks the bridges as per their optimization. The second table provides the results of application of analytical hierarchy process, and finally, what is the feasibility to undertake repair and rehabilitation. This thing provides you the cost-benefit analysis. This completes the entire bridge resilience system process. We now can revert to the first summary page. Here we are able to see the summary of all the bridges for the full inventory. Summary is presented as per the structural status with the reference to the cause matrix and also with reference to the bridge structural rating number. For every cause, we see the percentage of bridges that are affected by that cause. Rating numbers are used to define the percentages. Similarly, structural rating for average rating of 2 and average rating of 3 and average rating of 4. We have the percentage of bridges within each rating number. This is aimed to provide any decision making official with one image ready reckoner as to what is affecting the bridges in his inventory. Similar image is created for the risk and vulnerability status of all the bridges with respect to flooding, cyclone, landslides, and earthquake. Here we can see how many bridges are there in the extreme risk category for each of these hazards. In our case, it is observed that only flooding has 1 bridge in extreme risk category. For all other 3 hazards, there are no bridges under extreme or high risk categories. Multi-criteria decision-making provides you a tool about what is the rehabilitation cost, and what is the resilience enhancement cost, and what is the balance available cost decision-making tool. The last image provides the number of bridges marked for immediate rehabilitation, and also for planned rehabilitation. This summary provides a good place for highlighting the full inventory summary at a glance. One need not go into the details of other pages. Now you can log out by pressing the Logout button. Thank you for your attention. We request each of you to kindly ensure to read the manual and implementation procedure to get better understanding of the whole process. Hope you explore successfully Bridge Resilience System.